There we are. Good afternoon, Jan.
Good morning, Michael.
Yeah,
Um,
we were just exchanging files. You extracted a bunch of knowledge files from all of our videos.
mhm,
So we were looking at the contents of those.
yeah, and the Jinaga expert is really helping me a lot.
Excellent.
Um, if I want to know something, it brings me directly to the correct video, and it answers the questions quite accurately. So I'm happy with it. Um,
Yeah,
it
and
makes my life a lot easier now.
excellent. And so it is currently installed as a skill inside of the Nowis uh, application or the Nowis repository.
Yeah.
So, are you using it while you are working on Nowis, or are you going to that repository, um, but then
Well,
working on
well,
something else?
well. For the moment, I haven't continued on Navis, so I put it in a separate branch,
Hmm.
which you saw in GitHub.
Yes,
Uh,
yeah, I've got that
you,
right.
you saw the mail.
Hmm.
Um, I've been doing some research this week, um, looking back into the old episodes about all the things we discussed, also about DWS, things that I need now in Nowis.
Mm, yeah,
But so in all this research, it's very helpful. Um, one of the simple things where we discussed a lot before, and that was what I was looking now at this morning. Um, when you made that Nowis model in video 258, I
hmm,
think you said the preference is to link, not use a reference database with customers and systems, and make a copy of it, but really link into the main database.
yeah, yeah. So I think we were talking about. So was this the point where we were talking about having a kind of a shared database that several different people could use, or is this like
Yeah,
an external database? Like this is like SQL Server data,
well,
and
no,
and you're using those
the
IDs.
the purpose is that now is the clients, the weighing instruments, and the inspections will be shared by all the inspectors. So it will really be a replicator.
Hmm.
They sync with a replicator. Um, it will have then a database of customers, a database of weighing systems, and a database of inspection results. But also here, inspectors, the same system as with DWS, inspectors
Mm.
should be able to add a new customer, should be able to edit a customer, to correct,
Hmm.
even to delete one, but it has to be approved by the people inside the company.
Right. Yes. Yes.
Call it a dispatcher. Um, and that was a scenario which we discussed very long about DWS.
Yeah. Yeah. Okay. I do remember that conversation.
Yeah.
So
And,
yeah, the business problem is that the DWS entity you owns the correctness of that shared data, but um, a customer should be able to kind of see their own projection and modify their projection of it, and then also contribute back. But yeah, you
well,
need to authorize.
well, so I don't authorize. So my customers, a company who does inspections of
Okay.
weight scales,
Yes.
they will have their customers.
Right. Right.
So every single client of my clients has his own customers.
Okay. Got it.
Yeah. So each one is a tenant. Each client of me is a tenant. Um, internally, they probably have a CRM system,
Okay. Right. I do remember talking about that.
and
Yes.
and that's the master, the,
Hmm.
the source of truth
Hmm.
for the customers. But that means smaller ones don't have that. They have somewhere an Outlook database, I don't know.
Right. In Excel spreadsheet or yeah. So
But so in one or the other way, it's getting into Navis, into the database, and it's somebody inside the office who will make modifications either by importing, either by modifying it directly in the database. But the technician in the field, it might be that he says there is something wrong with this the
yeah.
customer, that the address is not correct, or the TVA number, the tax number is not correct. So you should be able to modifying it on the spot,
Hmm.
because no way that the software blocks the work.
Right.
So
Right. Yes.
he has to continue, and then that modification has to, he uses it for his inspection. It has to be proposed internally for approval afterwards.
Right. By the tenant.
Yes,
Hmm.
but it should also be available to other inspectors.
Right.
Imagine that it's let's say a big supermarket chain, and they have, for example, 50 um, weight scales. So they go there with 3 inspectors, and each of them start working. And the first one sees, oh, there is a problem with the address of the customer. He modifies it. Then the modification should directly be visible to the other ones as well,
Hmm.
even if it's not approved. And for DWS, we found a solution. It's not approved yet, but we show it to the other inspectors, but we mark it, for example, background color orange or red.
Yes. Yes. Yeah. Okay. Yeah.
Yeah, so
I
that
remember that
everybody
choice too.
can use it, but knows it's not approved yet.
Yeah.
Um, but the what is important here with the inspections is that the reports that come out of it, they are signed off by the inspector, and these reports, they cannot be modified anymore afterwards,
Hmm. Right.
not by accident. For
Yeah.
example, administrative data of the customer can be modified in limited ways,
Hmm.
but then the technician has to sign it off again, and the report will have a new number, and it will be correction of the previous number.
Yeah.
So that means that if we link to the main database with customers, and the database is modified somewhere in the future, and we reprint an old report,
Hmm. You still
then
get
the data,
the
we
old data.
still need the original
Yep.
information. So in that case, we cannot link to the identity of the customer, but we have
Right.
to link to the mutable properties.
Yes. Yes.
And is that something that is technically possible, or does that have
Absolutely.
side effects?
Yeah. That absolutely is technically possible and has exactly the effects that you would want it to have. Um,
Okay.
so yeah, you would be taking the that specific mutable property of customer address, for example, um, in addition to the customer fact as a predecessor. Um, the customer fact is technically redundant because the address also has the customer as a predecessor, but um, but you also it doesn't really make sense to choose one of the properties to be the thing that points you at the customer. That's just kind of weird. So it's like that customer with that address. So you form a little triangle out of those references. But
Sorry.
yeah, that means I render this address and it's a predecessor, and so that means it is captured.
Yeah, but so you point to that address and to the customer, two direct links.
Yes, yes, and um, yeah, that's mostly for kind of the feel of it. Um,
Mhm.
so a customer would have multiple mutable properties: the address, the name, contact information. So
You
if you
make a
didn't,
transaction property there.
yeah, yeah, it is the transaction pattern, and that it's capturing.
Yeah.
this specific set of predecessors, and now predecessors can't change. Um, and so if you were to leave out the customer reference itself, then you would have links to these three properties, and you could derive the customer from any of them or from all of
Yeah.
them. Um, it just feels a little weird to choose one to be the thing that you use to derive the customer. Um, Now it should be true that they all point to the same customer.
Mm.
That's not something you can enforce within the model, but that is something you can enforce within your application. Um, but um, but but yeah, it's just based on the fact that you are talking about a customer and you also want to know what were its properties at the time that this was recorded. It makes sense to capture the customer and capture its properties.
Because I'm still thinking, am I going to use that way of linking directly to the main data source? Still prefer to copy in and have my local copy.
Yeah, either way, you still get a local copy because the Jinaga model is independent of how subsets of that model are deployed. And in order for you to use um, a subset, whenever you run a specification, it has to pull all of
Mm.
the evidence, all of the facts um, that would result in that specification giving you its answer. So, so yeah, just by asking to to display a report, you are by necessity pulling in all of the facts that are necessary uh, to set up that report. And so that means, yeah, you do have a copy of that customer and these properties and their predecessors, everything that led up to that version. Um, but yeah, just doing that doesn't necessarily give you the other customers or the other history for
Yeah,
that
but
customer.
in, for example, in the replicator, I might have um, all my customers and all my inspection facts. And an inspection fact has, for example, the results, but also has the customer.
Mm-hmm.
And that could be a new fact, which is just a copy of the general um, customer fact, which is in fact the reference database.
Yeah.
So
So
that,
if you model that way as a new fact, then you're right. You don't that doesn't pull in the reference database to your local environment. Um, so yeah, you are in control via the um, via the specifications that you run locally. What subset gets pulled in?
yeah, because so every technician will have to pull in the reference database to have a list of all the customers,
Mhm.
all the weighing scales, and also its own inspections.
Right. Yes, and that's going to be true in either model, even if the inspections have references directly to the reference database when possible. Um, it's it's still true that you would want both specifications. The reason being that if you only have a specification in your local application that gives you all of your inspections, then a brand new inspector who hasn't done any inspections has absolutely nothing in his local database. Um,
Yeah,
and uh, and so in order to populate the the drop down lists of which customer or that sort of thing, those are fed by a specification that hits the reference database. And so
yeah,
pulling up that
mm,
user interface fetches the reference database into the local application.
mm, yeah. Um, but so does that mean that you are always in favor of linking to the reference database?
Um, I think that it's still a choice, and there um, yeah, the way that you model it has consequences, and so um, uh, by linking to the reference database, you are only making a copy when it's necessary to do so. Um, However, that does complicate the inspection facts. So, so the predecessors know their types, and so if you've got um, a customer that a technician has added because it wasn't in the reference database, um, you might model that as a different type that then once it's approved will the approval will be a link between those two facts, and those facts would be of different types, and that would be acceptable. Um,
Yeah, but in that case, what I will do is, if a customer adds his own, if an inspector adds a new customer, I make two facts. I make the fact that is belongs to the inspection,
mhm.
and I also add the same fact to the reference database.
Yeah. So I think it comes down to, and actually, I wonder if you've got a visual model handy.
I haven't tried it yet.
Okay.
We can go back to the visual model that you made in 258 or 259.
Okay. So yeah, we might try that in a second. So the uh, but first let's kind of talk through um, the difference between a customer being in the reference database and a customer not being in the reference database. Um, there's a couple of ways to model just that idea. One is that the reference database is a predecessor of the customer. And so now when you query for all customers in a reference database, you say, given this reference database, give me all the customers and then all of their properties, their current properties. Um, and so modeling that as a predecessor means that a technician couldn't create one of those facts because they would have to put it into the reference database immediately, and we would not authorize that. Um, then the other way to model that would be reference database is a fact over here. Customer is a fact where it doesn't have a predecessor relationship with the reference database, but then the approval, the accepting this customer into this reference database is a successor of both. So that fact
Yeah.
says I bring this customer into this database, and then a technician could create the customer fact um, and and use that, and it wouldn't be returned from the reference database query. But then once they submit it and say, I would like this to be included, if it's approved, then we could create that link. Say, okay, I'll bring this in, and now every customer is um, is approved in that way, and so you always have that associative relationship.
Um, because there is another another thing we have to take into account also. So for the moment, now is the way it is working, it's not syncing. And what they do is with Google Drive or with OneDrive, they just exchange the databases and they can import the databases.
Hmm.
So somebody, the responsible one who's responsible for the
Mm-hmm.
follow-up of the inspections, he gets by Google Drive or OneDrive all the inspection databases and he can import all the reports.
Mm-hmm.
That's the way it works now.
Yeah.
Unless one customer, he wanted to have to work differently from his dispatching. They have their own software. They wanted to send customer to a particular technician, the customer and the weighing instrument on which he had to work.
Mm-hmm. So doesn't
Um,
want to send the entire database of customers to that technician,
no,
just this one.
so that's and he wants to have the results back.
Yeah. Yeah.
So there, I for them I developed a special interface. But so the workflow is different. All the other customers, if we use Jinaga, They want to have the full customer database
Mm-hmm.
available and the full weighing instrument database for all the technicians. That particular customer, he sends a task to a technician.
Mm-hmm.
The technician does the inspection. The result goes back. Customer and the weighing instrument stay for, I think now for 7 days in the local database, which allows the technician, if he discovers there is something wrong with the inspection, he can still redo it.
Mm. Yeah.
He still has the data, but after 7 days, it disappears from the local database. But so
Yeah.
that's another workflow I have
Uh-huh.
to integrate into the model.
Yeah.
So I'm not sure yet how I'm gonna model that.
Okay. Yeah, I've got
Um,
some ideas on that too. Um,
but
but yeah. So this specific workflow is really calling for a particular model. So first of all, the model where the inspection is pointing directly at the customer that's inside of um, the database is the wrong model for this, because in order um, to to receive that customer, the technician must at the very least receive the database fact. Um, Now you don't have to grant them the distribution rule to be able to see all the other customers in the database. Um, so by that distribution rule, they can only see the tasks that were assigned to them, and then by inference their predecessors, which would include the customer. Um, so it well, so I guess having just walked through that, it doesn't rule it out. It's still possible to do that. You just wouldn't have the pick from the customer database feature on the technician application, and so it wouldn't be a distribution rule, and it wouldn't get pulled in. So yeah, that's still not ruled out. But that also does suggest a third option that that might make sense, and that is a hard separation um, between the customer database and the task. Um, so it could very well be um, that the relationship between the task and the customer is in a successor, so it can be hidden. Um, and the task, if you just look at its chunk of the tree, um, its its successors, not including that one that's hidden, can be uh, can be understood without any knowledge at all of the customer database. Um, and so that would argue for um, a different customer type, um, maybe even if you wanted the task itself to be immutable, um, then copying all of the data into it rather than um, having separate facts for the customer. Although that means that you can't correct something on the task. Like you show up in the reference number is wrong on the equipment, so let's correct that. Um, but yeah, so it sounds like um, yeah. So let me ask, when you designed this separate customer fact, was it a completely separate fact type, or just a different
in
instance of the same
the
fact?
software like it is today,
In the Jinaga model that we
I haven't
okay.
designed anything yet.
Okay.
Um,
Yeah.
but
So
what I did before was actually an inspection. Has a customer has a weighing instrument, and so what I did was the dispatcher. He started in fact an inspection. So he started an inspection in the sense that he already added the customer and the weighing instrument, and that is sent to a particular technician. And so that
hmm
that technician or inspector, he opened that inspection record, and he started the inspection and added all the results. So in fact, a task is just the start of an inspection in that sense.
Yeah. Yeah, and that makes sense. That matches the workflow. Um, yeah. Yeah, so I think I think the open question is, it really just comes down to the identity of a customer. Um, are there multiple identities? Are there even multiple types? Um, so every time, so if it's a separate type, uh, then you would expect that every time you assign a task, you make a copy of the customer,
Mhm.
and um, and now you've got a copy of the properties of that customer at that time that you made the copy, and you're copying them into different types because they don't share a common predecessor type. Um,
Yeah.
these have a predecessor that is the database. These don't have that predecessor at all, so they have to be different types. Um, or I guess it could be optional if you wanted to reuse the type, but yeah, I don't know if that that just complicates things, I think. Um, so so you're making a copy for each of the tasks, and then you have to think about when the task is complete, and you submit that. Does that is there a workflow for the the dispatcher to see the corrections that the technician has made? Like, oh, they
Um,
changed this number, they changed that address.
at this moment, no. But so in the new version, uh, that would be uh, that would be a
Yeah,
good thing to have.
yeah. So that's sounding like the nice clean model for doing that. That really expresses the intent. Um, yeah, most of the time you will be creating a brand new fact, which is a copy of something that was in the reference database, um, and not updating it. Yeah, the happy path is everything was right. Um,
Yeah.
and so yeah, you might get that gut reaction of like,
Mhm.
oh, I'm making copies every time I do this. Shouldn't I reference the original one? But yeah, I think the overall the overall business problem is really nudging us toward that copy idea, and that once we've accepted that simplifies a whole bunch of the other decisions that we'd make afterward. Yeah, so I think that
Um,
is the right direction.
because the if we copy for that particular customer of mine that sends a task, of course, when an inspector corrects something, that has no influence on the other technicians immediately.
Right.
Yeah. Um, for all the other customers, when he corrects something, the correction should be done in the copy, but also in the reference database. And in the reference database, the dispatcher will approve it later on.
Yeah.
Uh, in the copy, there is no approval necessary. The technician, uh,
Hmm.
he uses it that way, and that's it. He's the
Yeah.
one who signs.
Yeah.
But for future use in the reference database, the dispatcher will approve it.
Right. Right. Yeah, so the timing, as you were just pointing out there, is important because copy is both a noun and a verb. So you copied that information at a particular point in time. That was a deliberate action because it created a brand new fact. And so, um, do you want the approved corrections to be visible after the task has been created, but before it's been finished? So technician is out in the fields. They've had their
Yeah.
assignment, and then the dispatcher approves a correction. Does the technician immediately see that?
Ah, you would like with a watch to come the information to come true.
Yeah, it could be a watch, or it could simply be
Yeah.
that they pull up their phone after the approval has been made, and so then it does it does another fetch just to see, hey, is there any new information? Um, uh, but uh, but in order for it to do that, it does need to have some provenance, some causal relationship with the customer that it came from.
Mm. Well, the second technician that is working there, imagine that he starts a little bit later, and by that time the modification is approved in the reference database.
Mm-hmm.
By the time he wants to select that modification, he will see directly the correct,
Yeah.
because he starts from the reference database.
Okay.
But
Yeah.
I think once that an inspector has selected a customer or made a modification, it should not modify anymore.
Mm.
Because for him, that was correct. He
Yes.
decided that that was correct. He continues his inspection. If behind his back things are gonna be updated, by the moment he signs,
Yeah.
he has to go back and verify everything.
Yeah. Yeah. And you lose trust in the system. It's like, no,
Yeah,
that's not what I put in, because he might not even catch it after he goes back and
yeah,
re-verifies. It's like, oh,
yeah.
somebody else changed something, and I just signed my name to it. No.
So I think it's really a copy
Mm-hmm.
that is immutable at that moment.
Yeah. Okay. Yeah.
Um,
Yeah. So yeah, the
and,
business problem decides the model.
mm,
Yeah. And so
and
yeah,
then
getting back to your original question, would you always recommend referencing the yeah, directly referencing the reference database? No, we would have to talk through everything that we just
yeah,
did in order to make that decision.
mm. And for example, for the weight scales, uh, because we said we have a lot of mutable properties, I would in fact limit it to two mutable sets of properties. One are the metrological properties,
Mm-hmm.
and one are the administrative properties.
Mm.
Administrative, for example, a serial number, for example, the name, things like that.
Yeah.
Metrological, the maximum, the minimum, everything that has influence on the inspection itself.
Right.
Because it might be that after performing the inspection, at the end, the inspector gets a full preview of the report before he signs.
Mm-hmm.
And he says, oh, I made a mistake in the serial number. Well, there was nothing that that prohibits changing that serial number before he signs off the report.
Right.
But if, for example, he made a mistake in the maximum value
Mm-hmm.
or in the E value or in the minimum, that has an influence on the whole inspection.
Yeah.
So
Yeah.
there is no way he can change that.
Yeah.
That is why I would make two different sets of mutable properties.
Mm-hmm. Yeah. Yeah. I would agree. Definitely would. Definitely would have to be included in the model. And I'm wondering if those those relationships in the measurements um, should be encoded within the model as well. Um, they're a lot more complex, so um, it might not fit. But yeah. So if you've got a mutable property that just captures all of the you know, all of the measurements, all the metrological uh, properties, um, then then it's really up to the application and the technician to make sure that when we change this, we also invalidate these and recalculate those.
Mm,
And then do that capture and now capture a complete consistent set. Um,
mm,
and that might be exactly right. The consistency of the measurements is not captured in the causality of the model, um, but instead is part of the business rules and can be validated after the fact as well.
yeah.
Um, yeah, yeah, sort of like the chess game example in the book. I show two different ways of modeling a chess game. One where each move references as a predecessor the prior move, and you create a chain of moves through
Mm,
the game. And the other one where It's just each move is a direct successor of the game, and it just carries the index. So
Yeah.
so the fact that you have a sequence of moves um, is is kind of enforced by that first version of the model. With the second version of the model, you have to then inspect it and make sure that the indexes are sequential. Um, the fact that the players alternate turns can't really be represented in the model, and certainly not the fact that pieces move in certain ways. Um, all of that uh, is business validation that is outside of the model, and it feels like this is an example of that, where the business validation of the correct dependencies among these metrological properties is outside of the model, but capturing them as a consistent set, as this is just
Okay.
one set, um, lets you um, it lets you have that assurance that the client software and the technician saw it in this set, in this form, and saved it.
Okay.
Yeah.
Um, then another question in that video about now is that you made about the model when I was not there, the Christmas
Mm.
video.
Yeah. Yeah.
Um, so you made the model, the
Yeah.
view,
Yeah.
and in the view model, you made a routine that established all the test points.
Mm-hmm.
But
Yeah.
that's actually, why do you put that in the view model and not in the model? Because these test
Mm-hmm.
points are part of the metrological domain
Yeah.
and not really a matter of how the view is displayed.
Yeah. Yeah. I think the reasoning in that video was dependent and independent variables. What depends upon what? Um, and so limiting the degrees of freedom, so you only capture the independent variables and then you can derive the dependent ones. For this, yeah, for this domain, I think that that probably is the wrong choice, given everything that we were just talking about. That we need to sign off on this specific set of inspection points, for example. Um, and so yeah, that would mean that if somebody changed the software because the procedures changed and now we choose different inspection points under different conditions, now you could pull up an old report and it would run this new code, compute different
Mm.
inspection points, and that would be wrong. So yeah, I think really my analysis of what was independent and what was dependent is where the flaw crept in. um, so yeah, I would, instead of making that part of the view model, I would make that a utility function um, that is, these are all of the procedures as of this date. These are this is the manual that was published at this date. Here's a class. It's got a whole bunch of functions that calculate things according to those procedures,
Mm.
and then you deliberately call that um, when when you're setting something up, get the results, and then save those as a fact. So now it's like uh, we uh, we used this utility function, we got back these results, and now this is what we are going to going to use, even if that function changes, even if somebody publishes a new manual, and then we've got a new class with some new functions. Um, like those are preserved. So yeah, I think you're right. I think that was a mistake.
But I think the dependent and the independent variables is still very valuable
Mm-hmm.
for the inspection itself at that moment. It's just the moment that I have the dependent variables, the results of the inspections,
Mm.
at that moment I'm gonna save them as inspection results
Mm-hmm.
so that 20 years later, if I want to reprint that report, legislation has been changed, but I still have the old results, which I can just print out.
Yeah. Yeah. Yeah, and actually I think that is how it ended up. is that the view model would calculate these dependent variables. They would be displayed, and then as you entered your your values, it as kind of a side effect of capturing that value, also captured the points that were calculated. Um, the thing is, I don't know if I don't know how much weight the view model put on the calculations versus the model. So uh, if it loaded a model and it had different inspection points than what the view model calculated, um, what would it do in that case? It should honor what was loaded and ignore the calculated ones. Um, but yeah, I'm not sure that I coded it to do that. Um,
Mm,
yeah, and as I think through what you would have to do in order to make that work, um, it sounds like you're losing all of the benefit of having the dependent calculations in the first place, and doing that imperatively, as in right now I want to run this calculation and then it's done. Um, that in this case simplifies things. So yeah, I think as a general pattern, um, having dependent calculations inside of a view model usually makes sense. But yeah, even um, in the case that we just described, where the actual report does save the inspection points,
mm,
I think imperative still makes more sense in this particular domain.
yeah. So one of the guards I will have to build in. At this moment, we can um, you can interrupt an inspection and continue the inspection on another computer with the new
Mm-hmm.
Jinaga system then.
Mm-hmm.
Um, but imagine that you do it with an old software version, and with the first release of Jinaga, and then legislation has gone forward, and then you resume with the next generation Navis version,
Yeah.
then you get into troubles.
Yeah.
So I have every time I modify it, um, I just have to check with which software version it was made, and do you resume with the same version, and otherwise forget it, restart from zero.
Yeah. 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 And I think if you honor the model, um, as yeah, that's first class. That is the source of truth. Then you're going to find that you run into those problems a lot less frequently. Um, so that sounds like the best default in this case. Um, and I think it also makes sense as you ship new versions of Naus to retain the old calculations. Um, I would I would retain those not as Naus version numbers, but as metrological standards version numbers. So if you've updated Naus in order to implement a new set of standards, then you would have a class that is named using that new set of standards, in addition to the existing class that's named with the naming the old set of standards. And then there would be something in the model that tells you which standards to use. So
Yeah,
maybe it's explicit on this task. It doesn't matter. You're not just assuming based on the date. These standards go into effect on this date. You're not assuming that just as you show up, what date is it? Oh, okay, I must use those. But instead, when you create the task, you say, here's the task, measure this equipment using the standards that were published and effective on this date. Um, and then all of
yeah,
that is deterministic and captured, which I think
mm,
is the most important part of this domain.
yeah. Because in the old software, this history is kept, especially in the printing of the report.
Mhm.
Because so I copy every inspection is a full copy of all the data. But when I want to print it, I want to print an old inspection with a new now is version.
Mm-hmm.
At that time, software has to look how was the layout at the moment that it was created.
Wow, even the layout of the form, right? Yeah, that would
Yeah.
change.
So
Yeah.
the layout might change, and also the database version.
Mm-hmm.
With the old Navis, even if you take Navis from today and you get a database from 2001, you start up your Navis and he will go through all the database versions. He will automatically upgrade
Mm-hmm.
until he gets to the newest database version. Um, and then he will continue.
Yeah.
So
Yeah.
customers weighing scales.
Yeah, so that's actually something that I won't say you get for free, um, but that uh, you have to think differently about in Jinaga. Um, when you upgrade a database, if the database upgrade says there's a new column in this table, then that new column is added to all of the rows in that table. All the existing rows have changed now, because now they have a new column that they didn't have before. Um, and and that in and of itself is a problem in this kind of domain. Um, so so the thing that you get for free is that the existing facts don't change their shape; they are
Mm,
immutable even in the shape. Um, the thing that you don't get for free, and you do have to think about, is that as you change the code, the C# record that represents a fact in code, um, it's going to try to load an old fact into that record, and it's going to make some intelligent decisions. It's like if it sees a property in the old fact that's not here, it's going to drop the property. If there's a property in the record that doesn't exist in the old fact, then it's going to use a sensible default for it. Like if it's an integer, it'll get
mm,
a zero, that kind of thing. Um, or if it's nullable, it'll get null. So uh, I think that in this domain, it might even be important to have multiple uh, versions of the fact record, and you can do that um, by using the fact attribute that you have to put on the record in the first place. You put that same fact name on multiple fact records, um, and then you can name the record according to the version number, or put those records in different namespaces. Um,
yeah.
because the namespace is really just part of that name. So now the C# class name is not one-to-one tied to the Jinaga type. Um, and then uh, when um, when you write the specification to hydrate those facts, um, the fact that you use while writing the specification, that actual type, is the one that it chooses in order to hydrate. So you could write two separate specifications. One that loads the version, the 2023 version
Mm.
um, into memory, and one that loads the 2025 version into memory. Um, and so those reference different C# types,
Mm.
but
And then in the projection of the specification, there I set the necessary default values for fields that are not available.
yeah, 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 exactly. So yeah, and then if you need those two specifications to somehow combine and to be displayed on the same user interface, for example, then you're putting interfaces in the right places. So these two records can implement the same interface, and then uh, yeah, when you run those specifications and you get the 2023 instance or the 2025 instance, you can then uh, you store that in a collection of interface type, and then you can use it as if it you can use it as a combined space. You don't really care which one it was.
Mm.
So
Okay,
yeah,
that's
that does take some planning and some thinking through, but you've got all the tools in the toolbox to express that.
that makes it easier than converting facts in the replicator.
Yeah, yeah,
each time we update.
yeah, yeah, and yeah, converting facts in the replicator is a permanent decision. It's made at a particular point in time. Um, yeah, there's and it truly does make a copy because the
Mm,
original ones are still there. Um, yeah, there's a lot that can go wrong uh, by touching the old data and converting it to the new data. And so the fact that that's the default when you're using a relational database and you migrate the table by adding a column, um, that that default just that doesn't seem right to me. So yeah, this way you have to be explicit about it, but you get to be explicit about it.
mm. Okay, I will think about that. Let me see the questions I still had because I wrote down
Yeah.
a lot of things, but what is most important?
Well, it
Ah,
might need to wait until next week because we are
the
running out of time.
inspection, the elite. Okay, I think the most important one is we have an inspection. We have multiple types of inspection. Yeah. So far we had seen um, the weight which goes up and then down. But there is also the corner points of a weight scale that you have to inspect.
Mm-hmm.
A weight bridge for cars, you roll over it, you stop in the beginning, in the middle, at the end, you go
Mm-hmm.
back. Do you have every time? So there are different tests to perform.
Mm-hmm.
So I think there I need to make a collection of all these tests. Um, then the sequence can be changed
Mm.
within limits because it depends on the legislation.
Mm-hmm.
Inspectors can say, I want to add an additional test. So that becomes a really big mess.
Yeah.
Uh, I was thinking of doing it with a collection of inspections, but we will see that next week.
Yeah.
I will
Yeah.
try to make a model for that, and then let's see
Okay. Yeah.
what I can come up with.
Yeah.
Uh,
That sounds like a good one to cover next week.
mm, anyway,
All right.
now with the Jinaga expert, I can really I ask AI, when did we discuss that, or what were the findings? Uh, what were the conclusions? What were the thinking about that?
Mm-hmm.
And it comes up with a summary and all the links, and that makes it really easy now.
Yeah. Yeah. And now this video can be another one that it indexes.
Yeah, but this one I haven't forgotten yet.
Yeah.
um, I also looked at the whole process, your video for improving,
Mm-hmm.
and also the global site video. I looked once again at them. I think I start understanding it now. Um,
Yeah.
but
Yeah.
so
So
if I
that's the.
understand well, the so the orchestrator, if you want to have the automatic workflow from user story to quality code,
Mm-hmm.
the problem we still have now with Jinaga is that where with entity framework, the artificial intelligence knows
Mm-hmm.
already how to implement the database tables.
Yep.
With Jinaga,
Yeah.
that's still a
It
little bit
doesn't know.
the missing link.
Right.
Yeah. So the MCP server might help there, but I'm
Right.
gonna try
Yeah.
that. I'm gonna try that out.
Excellent, excellent. Yeah, yeah. And that's what I'm building the Jinaga skills for. So it's not intended to be the Jinaga expert, as in look up all of the source material and historical modeling. It's intended to be these are the patterns that are used in historical modeling and how they apply to C# or to TypeScript. So that's it's intended to be exactly um, what the agent then uses in order to run the orchestrator and implement a unit test
Factory.
or a user story. Yeah,
Mm.
yeah,
No, that would be if I could get all that working, and I just have to tell the computer what I need and verify everything.
yeah, yeah. Well, the new version of the skills are published right now on GitHub. So github.com/jinaga/skills. Um, So you can use open skills in order to install that, and you get this
Okay.
this huge set of skills. So yeah,
What
now I'm
what changed? What changed in the skills?
yeah. Whereas before it was just one or two skills that were derived from working with a with an application. These are um, uh, yeah, these are the result of a session where I explicitly asked the LLM to break the skills down according to how they would be used, um, and um, and so it's a much finer, detailed breakdown, and the skills are a bit more a bit sharper. They
Okay.
go straight at a particular problem. And this one has an eval framework set up. So um, yeah, I haven't fully exercised it yet, but the intent is
Mm.
to use that eval framework to optimize these skills, to minimize the token use, minimize the errors, to truly get the best results out of them. And then as models progress, yeah, tweak the skills in order to work best with the new models.
Anyway, the token use, I was at 50%, and all at once it dropped at 33%. So Cursor increased
Hmm.
the amount of tokens included,
Ah.
but they made a change to auto as well.
Oh,
So
they've got intelligent auto for.
they don't have, if I understood well, they don't have a price for auto anymore. Auto switches between the
Okay. Yeah.
most suitable model,
Yes.
but you are charged based on the
What you actually
price
use. Yeah.
of what you use.
Yeah. 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 That makes sense. I think that's a decision that they had to make. They were kind of
Mm.
forced into that. Um.
But
Yeah.
I
And.
think for the simple things, Composer, and for the difficult things, Grok is
Hmm.
seems to be working very well,
Yeah. Yeah.
and it's
And
way cheaper than Opus.
yes. Yes, indeed.
So
All right. So
it's
yeah.
it's fun. It's fun to play with that. And
Yeah. And
I have
we'll see how things have changed by next week.
yeah, and I'm able to concentrate again on Jinaga, and that
Yeah.
makes me happy.
Yeah.
I see progress. Okay, Michael. See you next week.
All right.
Until then.
I will see you then.
Okay. Bye bye.
Bye.